Okay, so this is for the students who are absent or anybody that just wants to go back through. This is the day 3, which is all the special segments and triangles. Topic 3, I'm going to go over the triangle mid segment. And then if you just need if you were here for the first part of this lesson and you missed the back 3 pages, then you can just fast forward in the video for the centers of triangles page. I'll go through that. So the triangle midsegment is one of the special segments inside of a triangle. It connects the midpoints of 2 sides of the triangle. And that is important because if it's not the midpoint, then it's not a midsegment. So if it's not connecting to midpoint, it's not a midsegment. But the midsegment in this picture would be DE, segment DE. And if a segment joins the midpoints of 2 sides of a triangle, then it is parallel to that third side and half as long. Okay, so DE is parallel. We can mark that with arrows to AC, and it's also half the length of AC. So if AC was 100 units, DE would be 50 units. So the way that we write this statement here with symbols is that DE is parallel to AC, and DE is half AC's length. So remember, without the symbols, it just means the length from D to E. With the symbols, it's talking about the segment itself. They're very closely related, but it would be talking about, for instance, like an object itself versus how long the object is. So how long the object is from the end point of this pencil to the eraser to the point would be DE's length, how long that is, and the pencil itself would be the segment DE. Okay, so then what we want to do here is identify all the parallel sides. So remember, parallel sides they have the same slope. So if I take 2 utensils, writing utensils, and to demonstrate this, these lines would be parallel because they have the same slant, same slope. They'd be parallel if I move them this way or this way. Now they're not parallel. So these would eventually intersect. If I continue the lines, they would intersect here. Parallel lines would never intersect. So we're identifying all the parallel segments in this figure. And so you just want to look at, for instance, one side in the inner triangle is made up, X is the midpoint of QR and W is the midpoint of QS. So XW would be parallel to the segment, the third side of the triangle that we didn't connect the midpoints of, RS. Okay, so WX would be parallel to RS. And then if we did this segment here, WY would be parallel to, it's the same slope slant as QR. And then finally XY is parallel to QS. So you can go ahead and try number 2, just naming the parallel segments, and I'll write them on here real quick. But pause the video before you check your work. Okay, so it doesn't matter if you're putting the smaller or the bigger segment on the right or the left, and it doesn't matter if you have KJ versus JK, it's the same segment. Either way, it's fine to name it. Okay, so that's the first step in being able to solve the triangle mid-segment problems, is to identify the parallel sides. Then if you're given lengths of certain sides, we want to be able to cut the parallel side in half or double it. If they give you the shorter one, you want to double it. If they give you the longer one, you cut it in half. So if L, M, and N are midpoints, so L is the midpoint of this side, making these 2 equal. M is the midpoint of this side, making these 2 equal. And N is the midpoint of this side, making these 2 equal. And then that's in triangle PQR. If PR, so that this side of the triangle is 46, and then PQ is 40, and LN is 17. Find the measure of each of these segments. So what you want to do is figure out which segment's parallel to the one they give you, and then if it's the shorter segment, you divide the parallel side by 2. If it's the longer segment that you're looking for, then you would multiply the parallel side by 2. So LM is parallel to PR. So LM is shorter than PR, so I'm going to divide the 46 by 2 to get LM. It's 23. MN is parallel to PQ. This is longer than the segment, so I cut this in half and get 20 for MN. QR is parallel to LN, so I would take the shorter segment this time and multiply it by 2 to get the longer segment. Okay, so that's 34. And then MR, remember M is the midpoint of this side because it was connecting, they told us in the beginning that all of these points were midpoints. So if this is the middle point and the whole segment is 34 units long, then you should be able to divide these two segments by dividing 34 by 2. So 34 divided by 2 is going to give us that these are each 17. Okay. 4 is just like that, so I'll let you go ahead and try that on your own. And then 5, find the value of x. So this segment, they don't tell you in here it's a mid-segment, but we know that because it's joining midpoints of two sides. So this is a midpoint, and this is a midpoint. So the mid-segment is going to join two midpoints of two sides of the triangle, and then it's parallel and half of the length of the third side. So if this is half of the length of this segment, we want to either, we have two choices. We can either take this expression and divide it by 2 to set it equal to this, or we can double this segment length and times and equal it to this. So I'm going to do the second one. It's a little easier so we don't have any fractions to work with. We need 2 of these because remember this is only half of the length. So if this is 50, this was 100, then we would have to times this by 50 by 2 to get it to be equal to this side of the equation. So they're not equal straight up. You have to multiply the smaller one by 2, and then 2 of those sizes would be equal to the whole. Then you just solve the algebra. So go ahead and pause it if you need to, solve the algebra, and then check your answer. Okay, so for 6 you're doing the same thing. I'm going to let you guys solve those. I just wanted to show you a couple examples. But you're taking the mid-segment. That's the shorter of the two, but it's half of the length of this, so we need 2 6x plus 31s to equal a 19x minus 36. And then you distribute. So 12x plus 62 equals 19x minus 36, and then solve. So minus 12 from both sides is going to give us 7, plus 36 is going to give us 98, so x should be 14. Okay, on the back, 7 and 8 are similar to that. 9, it combines the concepts from numbers 3 and 4, and then 5 through 8. So just take one side at a time. We're looking for, well, they give us that these segments are our mid segments, and they want us to find the perimeter of the outside triangle. So if we were trying to figure out the length of JK, for instance, it's parallel to NO. So it should be double NO's length, so this will be 84. Okay, so you do the same thing for MN, find what side's parallel to that and double it. And then MO, find what side's parallel to that and double it. So this one is an expression, so we're going to do what we did for 7 and 8. And if I redraw the triangle with just those in it, it will be a little clearer to see that it's just like these problems now. Okay, so x will be 8, and they want to know the perimeter of triangle JKL. So we already have 2 of the sides. We need to plug in here to get the third side. So what is that? 4, 2, so 104, so 94. So 94, 84, and 98 will give us the perimeter of the triangle. I'll let you add that. Alright, so then tip through the end is now dealing with angles. So segments are different than angles or sides. Every time I say side, I'm talking about a segment. Every time I say angle, I'm talking about two segments joined together, creating a particular degrees here. So these angles are going to be related. We've talked about a couple different types of angles in the previous units that we're going to use in this section to solve. The first being linear pair. So linear pair is going to be whenever you have two angles that are right next to each other in the sense of their vertex, which is their corner point that joins the two sides of the angle, is the same. So this angle 127 and then the angle 2 have a similar endpoint as their vertex point. So those two angles together, because they make a straight angle or a straight line, they would have to total 180 degrees. So these two total 180, so we can figure out what angle 2 is. So 53. Then we talked about corresponding angles. Corresponding angles are when two lines are parallel. They're only congruent when you have two parallel lines, which these are parallel since this is a midpoint and this is a midpoint, so this is a mid-segment. Remember, the mid-segment is parallel to the third side. So those are parallel. And then if I look at this transversal, this angle and this angle are corresponding. So if I redraw just like this, these angles here would be corresponding. That's where angles 1 and 2 are. Sometimes it's a little difficult to see when they've closed up triangles and added a transversal, but really these are just corresponding angles here and here, 1 and 2. So they'll be the exact same, so 1 is the same as 2. Then on the bottom transversal, on this transversal, 59 corresponds to which angle? Okay, 4. So that's 4 is 59. And then we have this other linear pair. These two together form a straight line, and they have to have the same meeting point vertex. And if this one's 59, then we can subtract 180 minus that to get that angle 5 is 121. And then for angle 3, we can use the triangle angle sum. We know the three angles inside the triangle have to total 180. So we have 112, and we need 180 from that. So 68 would be angle 3. Okay. So again, the three things that you're going to be using here, or actually potentially 4, so corresponding angles, because these lines are parallel, are congruent. Linear pair are equal to 180. Triangle angles equal 180, and also you can use consecutive interior, because 1 and 27 would be consecutive interior between two parallel lines. So same side interior equal 180. So consecutive, remember, is same side interior. Okay, go ahead and try number 11. Pause the video. Okay, step away for a second. All right. So if you tried number 11, hopefully you did it on your own, you would see that 1 and 5 correspond, but we don't know either one of those. So we have to start off with this 118 that they give us. It's a linear pair with 1. So even though all 4 of these angles make a line, when we say linear pair, we want them to have the same vertex, the same ending point. So 118, and we did 180 minus 118 is going to give us 62 for this angle. So just the two that share the common endpoint for their angle. So the angle here meets at this point, and then the angle here for 118 also meets at this point. So those two make a linear pair, not all 4 of them. Okay, then 5 we said is going to be the same. Okay, now we have to come over here. Angles 95 and 62 are in a triangle with angle 2. So those two together make 157. And we need 180 total for the triangle, so 23 is going to be angle 2 and angle 4. And then we just got 157 for these two, so the exterior angle theorem says that the inside two add up to equal the one outside that's extended from a side. So I know this is 157. Okay, then on the bottom, these 4, you're still doing the same concept, but you're only having to do one of the angle types. So either corresponding linear, same side interior, triangle angle sum. So these two angles, if you ignore this transversal, they are in matching positions relative to the vertex, so they're corresponding, so you would set them equal and solve for x. So identifying them as corresponding is super important because corresponding angles are congruent and lines are parallel, so you'll know that you can set them equal. You can't just always set things equal. Like on this one, you can't just set them equal. You'd have to identify these two lines as, if I ignore this transversal, same side interior. So they're pointing to these angles. So they're same side interior, which makes them equal 180. And then you solve. So I won't solve the last two for you, or you can set them up, but you can have another corresponding and another same side interior to solve. Okay, on to our special segments and triangles. So these segments are important because we're going to use them to figure out different missing angles and measurements inside the triangle. So we'll be able to figure out almost anything that we need to if we are given very limited information about a triangle. So a segment that joins the midpoint of two sides of a triangle is a midsegment. That's what we just previously did on the other page. So you can approximate the middle of this side and the middle of another side and connect them. That would be a midsegment. Okay, perpendicular bisector and angle bisector we've talked about. It's a line, segment, or ray that divides a segment into two equal or congruent parts, and is perpendicular, which means it crosses at a 90-degree angle to the segment. So because we have three segments here, and we're dividing a segment into two congruent parts, we can divide any of the three of these. So I can divide this segment if I want into two congruent parts, which means I'm really identifying a midpoint. And then I want a segment perpendicular to that. So it's going to make a right angle from that point. So that would be a perpendicular bisector. An angle bisector is a ray segment or line that divides the angle into two congruent or equal parts. So we're going to take an angle. Let's say this angle is 80 degrees. And we're going to divide it in half so that it's 40 on each. Okay. So the angle bisector doesn't have to go all the way down, but typically we will have it come all the way to the other side. But it's a segment cutting the angle in half. And you would have three because you have three angles here in the triangle. Okay, median is a segment that connects a vertex, so one of the corners of the triangle, to the midpoint of the opposite side. So if I try to find, let's say if we did vertex C, I think in most classes I didn't do C. Then I would find the midpoint of the opposite side and connect that. Okay, so that would be a median. And then the altitude is the last of them. This is a segment that connects the vertex of a triangle to the opposite side so that it's perpendicular to that side. So if I take A, for instance, I can take any vertex. I did B in class, so I'm just going to go through and do A. If I turn the paper so that BC is parallel with my eyes, then I want to drop a segment perpendicular to this. So it's going to be really close to point B. It might even be on point B if it was a right angle. The way that you can tell is you take a corner of a sheet of paper, line one of the sides of the paper up with BC and the other one up with point A, and it should make a 90 degrees. So mine was pretty accurate. Okay, and then these four are points at which those previous four meet. So the point at which the circumcenter meets is the perpendicular bisector. The point at which the perpendicular bisectors meet is the circumcenter. So each side has a perpendicular bisector. We'll get into this a little bit more on the next page, these three. End center is formed by the angle bisector. Centroid is formed by the medians. And orthocenter is formed by the altitudes. So you can pause that. Like I said, I'm not going to go through it that much in depth over here because these pictures are little, and this is on the next page. So just pause it and write those in, and you come over with me to the next page. Okay, so the first of the three is circumcenter. And this is created by perpendicular bisectors. for each side. Okay, so we have, let's say if we start with side AB. We want to create a perpendicular bisector. So we want to create a segment that is perpendicular to line AB that goes through the middle of line AB. So this XM would be a perpendicular bisector. For side BC, what would be the perpendicular bisector? Okay, MY. And then for side AC, the perpendicular bisector would be MZ. Okay. So certain things on here are going to be equal. The circumcenter is going to be equal distance, so equal distance from each vertex of the triangle. So really what it means is we already have a Roman numeral 1, 2, and 3. We'll just call this Roman numeral 4 to indicate that all four of these segments, BM, MC, and AM, are each equal. And what this circumcenter is if you were to draw a circle around the circle, as M is the midpoint, then it would be, since M to A would be a radius, M to C would be a radius, and M to B would be a radius, all three of the radius of the circle are the same. So the segments would be the same. Incenter is created by angle bisectors for each angle. So we have angle B, we want to cut it in half, so BM would be an angle bisector. Angle C's angle bisector would be what? CM, good. And then the last one, AM. And the incenter is equidistant from the sides of the triangle. Okay, so the sides of the triangle would be like AB, BC, and AC. So the incenter has a circle here in the center of the thing, so that XM, MY, and MZ are all the same. Okay, so if we look at these triangles, XBM and then BYM, they're actually congruent triangles because they both have a 90-degree angle here, connecting the side. So we have angle, angle, and then this shared side, BM, matches angle, angle on the shared side. So then the other two corresponding sides would be congruent. These two corresponding sides would be congruent, and these two. Okay, so again, once you've proven the triangle is congruent, and I'm proving BXM's triangle congruent to BMY's triangle by angle, angle, side, then all of the other corresponding angles and sides are equal. So even these angles in here would be equal to each other. These two would be equal, and then these two would be equal. But we're not going to do anything when we solve for those angles. Two more. The centroid is created by medians, which is a segment connecting, there's only 3 segments in here. The other ones had extra segments, but there's just BZ is a median. It's connecting the midpoint of one side to the vertex opposite that, AY and XC. And a median is created by, a centroid is created by a vertex connected to the midpoint of the opposite side. Okay, so point M would be our centroid here. And the significance of this is that it divides the segment into thirds. So 2 of the thirds, the longer segment, would be the 2/3 part. So really you can put another point here to indicate that this is 2 parts, 2 of the total 3 segments on that line segment. And then for the same thing for these other ones, the longer one out of this BZ segment is going to get 2 parts, and then the shorter one is just going to have 1 part. And then XC, same thing, 2 parts between M and C, and 1 part to the left of M. So I could give you a measure like BZ is equal to 30. I can say that B to Z is 30 units long. Well, because BZ is divided into 3 parts, you would divide 30 by 3 and say that each of these parts is 10. So then if they asked you for the length of BM, BM is actually encompassing 2 parts, so you would add 2 10s, and that would be 20. MZ is only 1 part, so it would just be 10. Okay. They could give you the 2-part, so they could give you that AM is 14. But AM is only 2 parts, so you would divide it by 3 because that was 3 parts. You're only going to divide it by 2. So that means each part is 7. So if they ask you for MY, then it's 7. And then AY would be 7 times 3, or 21. Okay, or they could give you XM, which is just the 1 part 1. Let's say they give you that's 5. Then you don't have to divide it by anything because divided by 1 is just 5. So all the third parts are 5, and that makes this 10. Okay, so that's how you use the centroid to solve problems. And the last of them is the orthocenter is created by altitudes. So you would draw in the height of every side. So if we look at this being parallel to your eyes, this would be connecting point B to the side here. If I turn it so that this is parallel to my eyes, I would want AY to connect so that it's perpendicular to BC. And then I can turn it so that this is horizontal and parallel to my eyes. And then I would join those. So where they meet is the orthocenter. And it's created by the vertex connected to the opposite side so that it's perpendicular to that side. Okay, this handle doesn't have any orthocenter problems, just the other 3. Okay, then we have all of our problems. And I apologize because these are super small and it would be nice to have a little bit more space. But I was trying to get a lot of problems in, so. Okay, so if G is the circumcenter of A, B, C, find each missing measure. So we're going to go back to looking at circumcenter just for a second. So on a circumcenter problem, all the segments on the outside are equal to the other segment on the same side. So those would be equal, those would be equal, those. And then anything from the middle to the vertex are equal. We don't have anything related, like MY, MX, and MZ are not equal. So in order to get those sides, or if we were missing something else, because we have right triangles, we can use the Pythagorean theorem. So what we're going to do for this one is we're going to identify all the things that we can based on what they give us. So if they give us that AE is 18, then EB is on the same side of that, and on a circumcenter problem, those things are the same, so that's 18. If AC's whole length is 30, then you should be able to figure out A to D and D to C. Each of those should be 15. And then if GB is one of the segments connecting the circumcenter to the vertex is 22, then the other 2 connecting the center to the vertex are 22. And so the only things we don't know in the picture would be GD, EG, BF, and FC. So if they ask us for any of those, we're going to have to use the Pythagorean theorem to find unknown sides. Okay, so AD is the first one they ask for, and that is 15, so we don't have to solve anything. Additional, we already have it. FC, okay, that's on a triangle on the bottom here, and on a circumcenter problem, these are all perpendicular. So our right triangle we're going to use is this one. If I draw it a little bit larger, I have a side 22 across from the 90, and then the side 9. So on our Pythagorean theorem, A and B are the 2 sides that border the right angle. So whatever 2 touch the right angle, those are A and B. The one that doesn't, which is across from it, is side C of the Pythagorean theorem. So when we do A squared plus B squared equals C squared, we're going to plug in 9 and B as A and B, and 22 is going to be C. Okay, the calculator for this part. Let's see. So 22 squared, I think is 484. Okay, yes, so 44, and then we already know 9 squared is 81. Okay, then we're going to subtract 81 from both sides. And take the square root. So it tells us it's 20 and some change. So the more exact answer would be to leave it as the square root of 403, because if we put 20.5 or 20.1, then it's really a little bit misleading because there's actually numbers behind that. So the most exact answer we could put is the square root of 403. That's what we'll put. Okay, then EB is 18. Okay, so we don't have to solve anything for that. AG was 22, and EG we didn't get. So we have to do the Pythagorean theorem one more time for EG, and we have 18 and 22. So with our right angle being at E on the triangle EGB, which of these sides would be C? The 22. Okay, because these sides that are touching the 90 are A and B. 18 squared plus B squared equals 22 squared. So we have 22 squared minus 18 squared, because we have to subtract this from both sides, equals 160. And then when we square root that, let's see if we get a decimal. So we just leave it as the square root of 160. So we get a decimal. Okay, and we're done. Okay, so we have another circumcenter problem to try. I want you to try this one. So go ahead and figure out from the things they give you what segments that you would be able to determine. So just pause the video, try it as many as you can, and we'll walk through this one. Okay, so Rx should have been 40, and XS should be 40, and then this would be 25. No other segments can we tell, because 9 isn't, it's a circumcenter problem, so it's 9 WZ and YZ that are not equal to anything else. So the first thing they ask for is QR. We can find QR. It's the length of two 25s added together, so 50. RZ, we do not know. So RZ, we have to find using the Pythagorean theorem. RZ is on two different triangles. It's on triangle RWZ and RXZ. But I would have picked the one that I know two sides of, because in order to solve the Pythagorean theorem, I have to have two sides known. So I would pick triangle RXZ, and RX was 40, and XZ was 9. And my right angle would be here, here, and here. So the side that should be C this time is the side that we are looking for. Okay, if you do all the math out, you get that C is equal to 41. So that means that RZ is 41. It also means that ZS is 41 because it's segment connecting the circumcenter to the edge, and QZ is 41. Okay, so 41. XS is 40. We already had gotten that. ZS, these letters are so close to each other. And then WZ. We don't know WZ. So we have to do the Pythagorean theorem again. And we can either use the top or the bottom triangle, but they're the same numbers. Okay, gave us a decimal, so we'll leave it as the square root of 1056. Okay, and that's how you do your circumcenter problems. Okay, then we have two in-center examples and two circumcenter, centroids. Sorry, we did the circumcenter. And I'll probably do two of the other ones on this page that are harder, and then you can try the back. So if C is the in-center of the triangle, find the missing measure. So this has some angles in it this time. So if we go back to the in-center problems, these angles are going to be the same because these are marked the same, these two are the same, and these two are the same. And every triangle's angles always total 180, so the triangle's angles here, here, and here would make 180. Okay. So things we can figure out from the in-center if you look at the previous page. On the in-center problems, the circle would be in the center, and all four of these are, three of these are 4. Okay, so this one's 4, all of these are 4. And if this is 30 because it's an angle bisector. This is 20, this is 20. And if we know in a triangle 230s, so 60, 40, and then we need to figure out the last angle. So we have 100 degrees so far, and we need the triangle to total 180. So 180 minus 180, 180 minus 100 is 80. So we have 80 degrees to split evenly, so each of these would be 40s. Okay, 80 for the whole angle, and then 40s for each of those. So those are all the things that we can figure out. Oh, and this 11 was given, which means this side is 11. Okay, so the angle CML. CML outlines this angle 20 degrees. If they were talking about the total angle, they would have called it JML. So CML means we're only starting here and drawing this angle. M and P is the combination of these two, so 60. And NPC is 40. And JC is 4. So we only have to do the Pythagorean theorem once to find MC. Okay, so on this bottom triangle here, we know 4 and 11, and we're looking for CM, or MC, the third side, so we can do, these are both touching the 90s, so these would be A and B, and you're looking for C. .137 is actually not a perfect square, so it's going to be 130. The square root of 137. Okay. On 4, if y is the in-center, find each missing measure. So in-center problems, again, these two sides match. So this is 24. These 3 are the same, but they didn't give us any of those 3. And these aren't the same as anything, so that's really all we can do. So VT, this is a T up here, it's 24. WYW is part of this triangle right here, so we can do the Pythagorean theorem. I'll let you solve that out. And let's just say it's 10. Then these would each be 10. Okay, and then SX, we have to do the Pythagorean theorem again with this triangle. So I'll let you solve that out. And SV would be whatever SX is, because these two are the same. So these will be the same. And these will be the same. Okay, centroid problems, there's 2 examples of those. So this is the one that's divided into thirds. So if they give you that G is the centroid, AG is 26. So you would first figure out if AG is the 2/3 part or the 1/3 part by looking to see if it's bigger on segment AF than GF or if it's smaller. So since AG is the bigger of the two, I'm going to redraw it over here. Okay, that's this segment. And they said the A to G is 26. Well, it's divided into thirds, so I'm going to include another dot here. So this is 26, which means each third, because that's the 2/3 part, I have to divide it by 2 to tell me that each third is 13. So this is 13, this is 13, and this is 13. So GF would be 13, and AF would be 13 times 3, or 39. Okay. So again, you're dividing the segment into thirds. You're figuring out that this is the bigger of the two, so that's 2 of the thirds, 2 of the 3 parts. And so 26 divided by 2 of the parts is 13, so 13 is each of these, and 13 is the last part. Alright, we're going to do another one. BC is 44, and DG is 12. I'll just write the ones they gave us. Okay, so FC, they want to know how much this would be on a centroid, you can go back to the figure and figure out what this side is equal to. So if you go to the centroid and look at see what this side is equal to, it's equal to the side right next to it. So these two have to be the same, which makes this 22. GB. Okay, so GB is on a segment D, G, B. And the part between G and B is the longer side part. So if this is 12, then each of these are 12. So G to B would be 2 12s or 24, and then D to B would be 3 12s or 36. Okay. And then 6 is also another centroid problem. They give you ln, which is the whole thing, so you divide it by 3. And each of the parts would be 24. So 24, 24, 24. So I'll let you figure out what LQ should be and what QN should be if all of these parts are 24. JP is 93. This is the longer part, so I'll divide it into 2. So 93 divided by 3. So 31, 31, 31. And then you can figure out those two. And 78 was the whole thing again, so you divide it by 3. So you can do, actually you can do 6 on your own. So please try this. Don't just give up and say, you get it. You're capable of getting this. You're just dividing it into thirds. If they give you the full thing, you divide the number they give you by 3, and then each of the thirds is whatever that number is, and then you add them together. So Q to J would be 2 of the thirds, so 2 31s. So if I do this one, it's 62. And I'll just do one of these. So Q to N was 124. So it's just 124. Okay. So that only leaves you 3 to do on that. Okay, so then there's some more circumcenter, in-center, and then all the mixed practice on the back. So this is the same stuff on the back. I'm not going to go through any of that. That's the practice for extra credit. Okay, so this is a circumcenter problem. It's a key to know which kind it is. If they don't tell you, then they have to give you some markings on the figure, and then that'll help you know. So if it's giving you markings like these two are equal, and then this is a 90 degrees, then you would know it was a circumcenter problem. Okay. Alright, so BE is 8x minus 11, and EC is 13x. Okay, so they happen to be on a circumcenter problem. You would look to see how these two are related. They're equal. So you're just setting them equal and then substituting x back in to find the whole length BC, so you add them together. So actually I'm not going to do that one for you. Number 8 is a little harder. So 8 is also a circumcenter problem. So BP is what they give us, but I don't have any space to write all that. And then AP and PF. So if we go back to the picture and look at what's the relationship between any of these 3 segments, the two that connect from the circumcenter to the endpoint or to F. The two that connect from the circumcenter to the endpoints are equal, but they're not equal to this one. So I can just set these two equal, solve for x. So go ahead and pause yours and solve for x. Okay, and we want to figure out as much information as we can to get to FC. So FC is over here. So we need to plug this in to see what these segments are, because PC is also the same length as that. So I plug it into just one of them. These are each 34. Now on this triangle I'm looking for this side. I have 34 and PF was 15. So I actually have a triangle with 2 sides known. So I need to do the Pythagorean theorem. I'll let you solve that. Figuring out which side is C and then doing a squared plus b squared equals c squared. And the answer should be 931, the square root of 931 if you did it correctly. But I want you to try that one out. This one's straightforward. Okay, number 10, I give you angle for RST. That's the full angle here. STR is the full angle here. TRS. So these things you should start to recognize. If you get angles that make a triangle's corners, they always equal 180. So you have to add them to equal 180. Okay, then once you get x, they want angle RSN, which they don't give us an expression for RSN. They give us an expression for RST, so we can figure out what this total angle is. And then RSN, since it's in center, would be, these two would be equal, so RSN is half of that. Okay, so the measure of angle RSN is going to be equal to half of the measure of angle RST. So once you get x, you want to take half, plug it in and take half of RST.